I want to thank everybody for coming out to the session. I know there's a lot of really good choices in this time slot, so I really appreciate you coming. So we're here to talk about moving Oracle and open source workloads to Azure and how it just keeps getting easier. So my name is David Levi. I'm a program manager with Microsoft. I'm on the database migration team. We are responsible for basically any kind of migration you could think of. If you're migrating a database to Azure, we're supposed to figure out how to make that happen for you. So our agenda today, we're going to talk about why Azure. We're going to talk about migration planning and tools. And we're going to talk about Oracle, PostgreSQL, and MySQL migration scenarios, as well as how to optimize your environment. Now, I've got a ton of content. The 50 minutes is kind of a challenge. And I've actually got 3 demos. So I'm going to ask to hold the questions till the end. Or if you want to put them in the, I forget the name of the app, Canopy. That'd be great. We can get to them at the end. And I'll stick around after. If anybody has questions or wants to talk more, I'll make time for that. So let's talk about why Azure. You may have noticed the last couple of years we've been undergoing this unprecedented change. And it really started maybe back in 2015, 2016. All this fourth industrial revolution talk started. And then things have really accelerated since then. We've got a lot of IoT, Internet of Things devices, a lot of AI and things like that coming in. So you're seeing huge disruptions in retail and consumer goods, healthcare, supply chain and logistics, manufacturing. I think every company is a logistics company lately. Everybody's trying to find stock to be able to sell. So what you're seeing is this migration from on-prem into a hyperscale cloud. And the idea is you start on-prem, you migrate, you get your workload out there, you modernize where it makes sense to, and then you start to innovate. You start to take advantage of things like machine learning, where you can take compute on demand, stand up these huge clusters and be able to do this analysis where it wouldn't make sense on-prem because you'd have all this hardware that's not running the other 29 days a month. It would be a waste of money. But in the hyperscale cloud where you can just borrow it and run it, it's a really good deal. So there's a lot driving the move to the cloud. When we talk about benefits of Azure versus on-prem systems, the first thing is that the data centers are taken care of for you. So you've got this globally available footprint. It's all enterprise-grade hardware. You don't have to go and sign contracts, go talk to ISPs, sign leases for buildings, maintain heating and cooling and things like that. You're really just going out and provisioning resources. So you get the flexibility without redundancy and the increased agility. It also, the biggest thing is it really allows you to run hotter. So on-prem, we always have this 3 to 5 year planning horizon. And I was a DBA in a past life, so I always got upset when they asked me to estimate what a machine size would be in 3 to 5 years. I'm like, I don't know what it's going to be a month from now because somebody from accounting might run a crazy query. But we had to guess 3 to 5 years, and if we got it wrong, we had to go through the budget request process, and there was a lot of really drama that went with that. Now with the hyperscale cloud, you're either moving a slider or you're rebooting a VM into a higher SKU, and you're moving on. It's not really much more than a conversation about re-upping a reservation. So, there's a lot of benefits to moving to the hyperscale cloud. When we look at what's available when we move out there are a ton of database offerings. So, naturally our favorite is SQL. We hope everybody wants to run SQL. But we do offer PostgreSQL, MySQL, and MariaDB from the open source when that makes more sense for your workload. We also have Azure Cache for Redis, which I think just about everybody that has a session state in their website is using Redis now. And then we've got Azure Cosmos DB. So if you're doing document DB, things like that, that's also a great choice. So let's look at some of the migration planning and tools. And we're going to set the stage here a little bit, talking about the cloud migration phases. How many people have seen this before? No hands? Okay. Well, it is kind of, if you've worked in IT for a while, it's kind of what you'd assume it would be. You have to discover, you have to assess, then you migrate, optimize, and then finally secure and manage. Some of the biggest and hardest steps here are the first couple. The discovery and the assessment. It's very, very hard to get your arms around everything that's running in your environment. You have an enterprise, has lots of servers. People are putting servers under desks. Departments are buying their own servers and standing them up. It's hard to get a good, accurate read on what you have. So being able to discover is a key phase. Right after that, after you've got your arms around the entire inventory of what you have, assessment is a close second. Once I know where everything is, I have to figure out what is it? What is it doing? Who's connecting to it? How big is it? How many CPUs am I running? Once you have that information and you've got a good read on what your workloads look like, then you're ready to migrate it. Now, there's only a few migration tools, so this actually gets easier and easier as we move across. When you're going to migrate, you're going to select a migration strategy, and really it depends on how important the application is and how tight your window is to do the migration. But once you've migrated, then it's time to optimize. That's where you're going to, like I was saying, take advantage of running hot. You're going to analyze your costs. You're going to look to, can I run all these resources at 70 or 80%? Can I really push the limits on these? Can I pull back a lot of CPUs, maybe save some money on SQL licenses or use them somewhere else? And then finally, secure and manage. Once you move to, say Azure, you've got things that are going to offer additional security features. So you're able to go and take advantage of those additional services that are going to make your environment more secure. Okay, so the first tool that I want to talk about is Azure Migrate. Azure Migrate is the primary migration tool. We're really trying to get every scenario into that. What it really excels at is at scale migrations. So being able to run this and do a discovery across your entire enterprise, see all the resources that you have, be able to start to do assessments on them. And for many of the scenarios, we do have migration as well. Despite the name, Azure Migrate, you think everything would migrate. We do have some scenarios, especially around database, that are pretty complicated. So we still use other tools to do those migrations. But for discovery and assessment, Azure Migrate is your primary tool to get your hands around what's going on in your enterprise, what kind of resources each of your applications is going to require, and then who is connecting to it. Next up, we've got the Azure Database Migration Service. Now, this is a service that's meant for, I have this application, I have this workload, and I want to move it to Azure. So this tool is going to basically handle it depends on the platform. I almost need like a matrix here. We're working on different parts as fast as we can. So like we have a different experience for Oracle versus Polybase, versus Postgres versus SQL. And we're working to make that all even and make them the same, but it takes time and resources. But the Azure Data Migration Service allows you to take a database, get it in sync with a production or with a copy in Azure, and then when you want to do your production cutover, you can do the cutover within the tool and just make it look nice and simple. In the past, we would have had to use log shipping or SSIS or replication or some other tool to keep the data in sync and then do our migration, where this takes care of that for you. And then finally, rounding out our core tools is the migration extensions in Azure Data Studio. Now, I feel like I want to talk about SQL. That's my primary area, but Oracle and Postgres are also areas where we can do where we can use the migration extensions in Azure Data Studio. Now, why you want to use the migration extensions is because they have the SKU recommendations. The SKU recommendation is, I think it's just the coolest thing, honestly. What we'll do is we'll take and we'll gather either perfmon data, or for Oracle, we can even use AWR reports. And we'll take that data, depending on how much time you collect it for, we'll pull it together, take the maxes on it, and figure out what size machines you need to go to. whether it be a database, we can give you the SKU for the database, but we can also give you the SKUs and disk layouts for VMs. If you've built a lot of SQL VMs or even Oracle VMs in Azure, the disk layouts are pretty challenging, getting the disk pools and all that all sorted out, doing the math. These tools help you figure all that out. So very, very nice. So let's talk about Oracle on Azure. We like to say for Oracle, we have a destination for every workload. I kind of put an asterisk on that because we cheat a little. So we do have Azure IaaS, which is the Azure virtual machines. You can build a virtual machine in Azure and just run Oracle out there, just the same as you would on-prem. We also offer the OCI interconnect. So you can connect to the Oracle database service for Azure. This is for workloads where you're running them on Oracle's cloud. So, say Oracle offers you a really good deal to use their cloud. What you can do is you can do that without giving up anything. It feels like there should be a trade-off. Like, okay, if I do that, I can't connect it to Synapse. I can't connect it to Power BI. But with the OCI interconnect, you're actually able to basically have a connection. Well, not basically, it is a connection to your Oracle data center and pull that data back and forth as though it's in one single data center. Now, we also have relational databases, so you can migrate your Oracle workload to Azure Database for PostgreSQL or Azure SQL. We also have the distributed relational and non-relational. So, Azure Cosmos DB does have the PostgreSQL functionality in it. Or you may look at your Oracle workload and say, you know what, we're not really using this database in a relational database sort of way. And this actually happens quite a bit. People are storing documents or something like that in a database, and this is their chance to get out of that. On-prem, it's a thing you would do because you had an Oracle server. You didn't have to go buy anything else. So you would store whatever in there. But when you do this migration, you have this chance to look at, should I do this better in non-relational types? And the same goes for data warehouse. If you're looking at moving a data warehouse out, this is your chance to go to Synapse. Whether you're on Exadata or some homegrown data warehouse, that's an option too. So when we look at the Oracle migration workflow, we do the discover and assessment, and that's going to be consistent across every platform. You always discover and assess. And then, where you go for the migration is kind of what changes. So if we look at Oracle here, rehost is probably the primary option. A lot of folks just like to have that control over their Oracle workloads, so they like to run it on IaaS or they'll run it on the Oracle cloud. Refactor is another option. Moving to PostgreSQL, we're seeing that a lot. That's very common where people are looking for, I've been paying a lot of money for licenses and I'm not looking to do that anymore, so I want to get out of that and go to open source. So that's where you'd see a refactor to Azure PostgreSQL. You'd also see the re-architecture like we were talking about, where you're looking at the application as you migrate, and you're like, I really never liked the way we built this application anyway. If we could do it all over, we would probably use Cosmos. So there you would re-architect. And then you've got replace with the Azure Synapse Analytics. So if you've got a data warehouse or you've got Exadata, it's a natural choice. And then kind of buried down here at the bottom, we have software as a service. In my personal opinion, and actually a lot of people share this opinion, there's no better way to run commercial software than software as a service. If an application is not core to running your business, if you're not able to drive unique value by your administration of a database or an application, why invest the time in it? Why invest the cycles? You can take it out to software as a service, and the vendor who actually has value in innovating and driving, a better use case or a better experience through that is going to be incentivized to do that. And you can go do other value-added activities that help you drive your business to the next level. So that's the Oracle migration workflow. Let's look at a demo here. This is assessing an Oracle migration, or Oracle to Azure migration, I should say. The cool thing about this one is this shows the SKU recommendation engine, so pretty exciting.
And I've already started the Oracle Migration Assistant extension. I've already got it installed and everything. But here we see that we're on the migration assessments. We see I've already run a few. And we can see under assessments here that we've got a SQL assessment that I've got that I just finished running. But let's go ahead and run a new assessment here. So I'm going to click Run New Assessment. I'm just going to take the name it gives. I'm going to do PostgreSQL for this one. I'm just going to do a workload assessment in the interest of time. And here's something I really want to show. This is cool. One of the hardest things in sizing SQL servers, or not just SQL servers, but any kind of server in Azure, is that you really have to get the sizing right. And this really hasn't changed much from on-prem. If you have a server that's maxed out, all you really know is that it needs more of a certain resource, whether it be CPU, memory, I/O. So you typically have to go bigger than needed to remove the constraint so that you can actually see how much of a resource it needs. So getting sizing right off the bat is a really, really good thing. And here we have the ability to take AWR reports from Oracle, and we can actually use those. So we know we're getting good performance information. And I'm going to go to my C drive here, my demos folder, and AWR reports, and I'll just grab my first AWR report. My scale factor, I'm just going to run it at 100%. My percentile utilization, we'll leave that at 95th, and we'll say run validation. And this just checks to make sure that all my files are good, that I haven't given it some kind of weird made-up AWR report or like for the wrong version of Oracle or something like that. Okay, so now that the validation is run, we can start the assessment. And this is going to run a little bit. Let's go here, refresh. Okay, so let's click on that. And we see right now it's doing the static data collection. And we'll just give it a second here for it to finish everything. Okay, so our assessment is complete. We can see that we've got a 73 on our feature compatibility score, and that we are looking at a memory optimized Gen 5 64 vCore with 64 gigs of storage, PostgreSQL flexible server instance. So if we click on view here, I can view the report details. And you can see here that we're getting, how easy would it be to convert? We have 40 things that are low complexity, super easy, just basically copy and paste them over. We've got 3 that are very high, and we've got one bit of code that requires a full re-architect. So there's, the majority of the workload is going to move very easy. There's going to be a little bit of work on 3 objects, and then, there's one object that we're really going to have to dig in on. And we can see, it tries to assign scoring to, how the different things fall in. So, we see the number of code objects, the number of storage objects, and the efficient estimated hours, how they play into those scores. So in the interest of time, let's jump over to database details, and we can see that, we've got our schemas listed, and for each schema, we have the number of tables that it saw, so we can do a little bit of confirmation. We can see basically all the objects, and we've got stored procedures, triggers, functions, views, everything right on down with estimated hours to do the conversions. We also see here we've got some overall knowledge of the server too. So, we see that the storage used is 7.62 gigs. We've got 51 owners. Our log mode is no archive log. Our flashback on is set to off. Here we can see we have 44 schemas, 44,000 objects. We don't have rack. So it lays it out really nicely for us. This is showing us our SKU recommendation and why we chose it. So, we chose 64 vCores because the machine it's coming from has 64 vCores. We got 385 gigs of RAM because that's how much you get with 64 vCores. So the AWR report wouldn't have shown that much need for memory, but you can never have too much memory, so we might as well use everything that we get. Finally, the storage requirement is 34 gigs. So this gets into that weird situation where you've got a machine that's got way more memory than it does data. You see that every so often. That just means that we'll be able to use all the memory we want. Should get really good performance, and it should actually lighten up our IOPS requirement a bit. So the IOPS requirement is only 640 IOPS, which it's very light. So you can see our source properties coming from the AWR report, where it told us we have 64 CPUs. It looks like it actually did have 384 gigs of RAM. We were running on Solaris, and it was using 22 gigs of storage. Finally, we get into feature compatibility, and we can dig into each of these to really see in depth what's going on there. But in the interest of keeping it light today, we're going to skip over that. So hopefully that shows how powerful the Oracle assessments are in Azure Data Studio and how they can really help you get the sizing right on the first try.
So I think that's pretty cool how it does the sizing for you and actually gives you. How many folks have built servers before or tried to build databases? A few. How many of you enjoyed looking through all the SKUs trying to figure out the differences between them? It's always like, am I making the right choice? So this takes care of it. It's applying the best practices for you, and it's really making it go faster and confidently faster. So I got to keep moving here. I'm going to get myself in trouble. Let's talk about PostgreSQL on Azure. So, the idea here is that we want to build on what Postgres already does well. We want to add in built-in HA, easy integration, good security, intelligent performance, and we want to give all that to you. And some of the top use cases here, we do see a lot of folks just moving Postgres from on-prem into Azure. There's a lot of Postgres popping up in different departments within companies, because that's what people can get to build up their own database servers and start up their own. I don't want to call it shadow IT, because it's usually blessed by like the business owner. But they're able to quickly start up and build applications. And then when IT has to officially take it over and support it, they're looking to put it on a good platform. Azure becomes a natural choice. Also, as I said before, there's a lot of Oracle to Postgres migration. A lot of folks looking to get out of the licensing game and go open source. And then you see a lot of cloud native applications too, where Postgres is the database platform that the development team is most comfortable with, and they're building transactional applications, geospatial, SaaS, or real-time applications. Now, Azure is the best destination for PostgreSQL. We all believe that. And the big things are that it's fully managed, that we offer that intelligent performance. We're surfacing that performance data for you. It's highly scalable. We give you that high availability and the maximum control. So let's look at some of the migration that you can do. We talk about the PostgreSQL migration extension in Azure Data Studio. And I'm going to have a demo of this, so it'll kind of show what it looks like. But basically what you do, the way the workflow works, is you install the Azure PostgreSQL migration extension. You run the assessment against your server, just like we saw with Oracle. You get to know your migration readiness, just like we saw in the previous demo. And then you're able to save off that assessment report so you can track changes over time, share them with other folks within your organization, whatever you might need it for. So, some of the benefits of really doing this, and really the two big benefits, are getting the sizing right, and so getting that target recommendation, and then finding out how much code you need to fix. The reports are going to be there. You can track things over time, but really it's about getting that sizing and finding out how much work you have to do. So the Azure Data Migration Service for PostgreSQL will let you do an online migration and sync changes from production to Azure, and then automate the cutover. So what you would do in this workflow is you're going to perform an assessment in Azure Data Studio, get that accurate sizing. Right now, you're going to migrate the schema using pgdump. So, we still force you to go to the command line for some stuff. but it's very quick to go to the command line for this. You're going to provision your database migration service, create the migration tasks, and then you're going to perform the cutover when you're ready. So I'm actually going to show, I've already provisioned the server in this demo, but I'm going to show everything forward from deciding to migrate, so doing the PG dump and all that. Well, why don't I just show you?
Okay, let's take a look at how easy it is to do an online migration of a PostgreSQL database to Azure Database for Postgres Flexible Server. So as you can see here, I'm remote desktoped into my machine. I've got the DVD rental sample database set up and ready to go. If we come in here and look, we've got all of the normal tables like you'd expect, actor, address, category, all of that. And this is what we're going to migrate to the flexible server. So what we need to do first is we actually need to do some scripting. So what we're going to do is we are going to use pgdump to script out the schema. Now, what we need the schema for is we need to prepare the database in Azure to receive the data. Basically, we get the structure out there, and then the migration service is going to come along and pump all the data out for us. So I'm going to enter my password here. And there we go. I've just scripted out the DVD rental schema to DVD rental schema.sql. Next up, what I need to do is I'm going to need to create the database. So I've got this all here in my autocomplete. I'm cheating a little bit, but it just makes it easier to type. Here we're using pSQL to connect up to my database on my flexible server and create the database DVD rental. So let's do that. And I'll enter my password. There we go. The database has been created. Next up, what we need to do is we need to push our schema out there. So that is right here. So basically what we're doing is we're taking that DVD rental schema.sql that we already prepared, and we're pushing that out to our DVD rental database on the Azure Database Flexible Server for PostgreSQL. Let's go ahead and run that. Type my password again. Okay, so my database is all created. I'm ready to start sending data. Next up, what we need to do is we need to flip over to the Azure portal. So I've got that here, and I've got a Azure Database Migration Service, the Classic. Basically, the big distinction between the Classic and the Gen 2 is that the Classic runs a self-hosted integration runtime in Azure in a engineering subscription, whereas with Gen 2, we give you greater control. So you are able to run that self-hosted integration runtime on your own servers. And that makes it a lot easier to connect, gives you a lot more control over how many resources that gets. So it gives you a much better experience in migration. Now, this will work just fine for a lot of cases, and for this it works great. What we're going to do is we're going to say new migration project, and we're going to say DVD rental, and we're going to tell it PostgreSQL, and our target server type is going to be Azure Database for PostgreSQL, and we definitely want to do an online migration. So, there's the two options, online data migration or create project only. Since we're doing the migration right now, we'll go with that. So create. Okay, so what I need to do next is I need to put in my server name. Now, I don't have SSL set up on my test server. I know that's bad, but it is what it is. So I'm going to uncheck the encrypt certificate or encrypt connection. And then I'm going to click select target. Okay, next up, we're going to select our target. Everything's already filled in for me except the password. So let's fill that in. And select databases. only want to move DBD rental. So we'll uncheck Postgres and select tables. Okay, here you can see that all my tables are selected. Let's go to configure migration settings. Now, I generally don't like to mess with the advanced settings. There's only one here, maximum number of tables to load in parallel. I'm just going to leave that alone. I learned a long time ago that next done through wizards like this is generally the best way to go. So next we'll go to summary, and we'll give this thing a name. So this is our activity. So we'll say DVD rental, online migration, and we'll do start migration. Okay, this goes really fast. So let's hit refresh and see if it's already ready to cut over. Let's go in and look at this, and you can see we've got our source and our target database. We're running, we're ready to cut over. We haven't had any updates, no inserts, no deletes, so no applied changes, but we can fix that. Let's go back to our remote desktop session, and let's hide the command prompt. Let's do a script, and we'll do an update script. So we're going to update actors. What we're going to do is we're going to set, let's go ahead. I know the first actor's last name is not Smith, so I'm going to make it Smith. And we'll say where actor ID equals 1. Okay. Let's go ahead and run that. All right, so we did get an update. Let's go look here. We'll refresh. And there we go. So we have 2 incremental updates. Actor 1 and Actor 2 both had their last name changed to Smith, and 2 applied changes. So, what we can do now is, say we're in a maintenance window, everything's shut down for the weekend. We want to go ahead and cut over this database and make the Azure copy our primary. We can click right here on Start Cutover and click on Confirm and Apply. Okay, so that's completed now. What we can do is we can go back to Remote Desktop and connect up to our Azure database. Let's go to schemas, tables, and actor. So we'll script out our select here. And the last update is automatically updated for us, so it's throwing everything to the end. Let's do an order by on here. There we go. So there we can see that Nick and Penelope were both updated. They both have a last name Smith now, and you can see that was just done. Right now it's 11:40, and this was at 11:36 and 11:37. So we are all moved over to Azure. This database is running on my Postgres flexible server in Azure, and it was just that easy to cut it over.
Okay, so next up, let's look at MySQL on Azure. Now, Azure Database for MySQL, it's kind of similar to Postgres. We take the open source and we offer the services on top of it. So we've got the fully managed OSS, the open source community database. You've got the Azure security, you've got the Azure high availability, and then you're able to use our cost optimization to really run hot and drive value. Now, historically, people have deployed to the MySQL single server, and now the flexible server is available. The flexible server is like the next generation where it's going to give you maximum control over your database, more flexibility, more for the mission critical type applications where, if you ask people, like if you ask the business owners, is it mission critical? The answer is always yes. When you attach cost, that's generally when you get a more honest answer. But, cost wise, this allows a lot more applications to become mission critical because it's affordable to treat them like that. When we look at the Azure Database Migration Service for MySQL, very, very similar. The big difference here is, in addition to the online migration, which is in preview here, we also have an offline migration. So if you want to take a copy of the database and push it somewhere, what you start to see is people are able to move databases. Like say you want to take a dev copy or something like that. This tool all of a sudden becomes very easy for that as well. And then in preview, we also have the ability to replicate changes. So if you want to keep pushing changes from one database to another, that option is available here as well. So we'll go real quick into the demo here. Basically, this is migrating MySQL to Azure. So we're going to see a lot of the same things. But it's nice to see that, how easy this MySQL migration is. So let's show that.
Okay, let's do an online migration of a database to Azure. So here we are on my VM, and I've got a MySQL instance running. I've got the employees database example all loaded up. As you can see, I've got the full 300,024 rows, so it's the full data set. We're going to go ahead and move that to Azure. So let's flip over here and go to our Azure Database Migration Service. And we're going to say New Migration Project. We're going to give it a name, so we'll call it Employees. We'll just call it Employees. And we're going to tell it MySQL. And I want to do this as an online data migration. So we'll create and run that activity. And my source server name is going to be that. Everything else is filled in for me, so let's hit next to select a target. Okay. For location here, we need to specify that, so let's go to West Central US because that's where my database is, or my server at least. Resource group, and there we go. Okay, let's give it my password. Okay, so what's going on here? Not available at the target. Well, that means I forgot to create the database. So let's go over here, and we're going to pre-stage that database. We'll say employees, save. Takes just a second to create the database. Okay, database is created. Let's go back and we'll do a quick previous and then a next. Get it to refresh. There we go, we've got employees. So next up, we're going to select our tables. And you can see it's already selected employees, all 6 of the tables. So next up, we're going to configure our migration settings. And we have the option to do advanced settings here. It's broken into 2 groups. We've got initial load settings and replication settings. And then within here, you've got a bunch of options around partitioning, task counts, batch caching, and then finally just the other bucket. If we look at replication settings, kind of the same idea. We've got source settings, target settings, and then other migration settings. I'm not going to mess with any of these. There's no problems I'm trying to solve, so I'm just going to hit next. And we've got to give it a name, so we're going to call it Employees Online. we'll click Start Migration. And this takes 2 or 3 minutes. So I'm going to hit refresh once, and then we'll do some magical video editing, and it'll flip to the replicate data changes when it's done. So we'll pick up there. Okay, so it's finished loading the tables and it's flipped over to the replicate data changes tab. Let's just flip back to the initial load tab here and see what we did. So it loaded 6 of 6 tables. It did it in 1 minute and 32 seconds. Not too bad. So if we look at the changes being replicated, we can see down here we're 0 seconds behind the source. We're doing really good. But we've had 0 rows inserted, 0 rows updated, and 0 rows deleted. Not exactly a lot of activity, but let's fix that. Let's go update a row. So I've got a query that I put together to change the data in the salaries table. If we look at the salaries table here, it basically it has a employee number, a salary, and then the effective date. So you've got your from date when it started and your to date when it ended. So employee 1001, I was just looking at this, and they're making 88,958, and they've been making that same amount since 2002. Here it is, 2023. Seems like time for a raise. So what we're going to do is we're going to update the table, and we're going to put an end date on the salary record that's currently out there. And then we're going to go ahead and insert a new salary record that is effective today. And we're going to bump them up to 90,000. So let's go ahead and do this. Run that. And there we go. We've updated them. Now we can go back and do a select. And let's look. Yep. So there's the end date, and as of today, the salary is 90,000. So long overdue. Let's go look and see how that's replicating. And we see we've got 1 row inserted, 1 row updated, and we're only 5 seconds behind the source. So we're doing really good here. Next up, we're going to want to do a cutover. So, assuming that no other activity is happening, that we're in a maintenance window, what we can do is we can actually just click up here and say Start Cutover. And basically it's saying, are you sure? Do you have anything going on right now? Have all your pending transactions been applied? We're looking at it, everything looks good. So we're going to go ahead and confirm this. And there's our cutover, and just like that, our cutover is completed. So very quick cutover. What we can do is we can go get our server name from the MySQL, and we can go back to our VM, and we can go ahead and connect up to our database here. And what we need to do is we need to put in our host name. Get our password. And for this, we need an SSL certificate. So we'll get our SSL CA file, which I've got stored out there. And there we go. That's all good. Let's go ahead and connect up to it. Now we see, here's our employees. Let's go ahead and look at our salaries. And there it is. So employee 1,000 or 10,001, I should say, they're making 90,000 now. That's their salary as of this date. So as you can see, it's just that easy to do an online migration from an on-prem MySQL to MySQL in Azure.
So I think this is pretty cool. I mean, this is something that when I was a DBA, I used to struggle with a lot, moving data around even, trying to keep it in sync, get clean cutovers, even getting a database schema scripted over and moved. It just all happens so fast now. So, I mean, that's really the key takeaway here is these tools help you go a lot faster. They take all the thinking and guesswork out of it, and it just guides you right down the happy path and gets you migrated. Okay, so let's talk about optimizing your environment. One of the key things to do is optimize your costs during and after the migration. We do have tools within the Azure Migrate that will help you calculate your TCO, make that business case to move. But more importantly, we have the resources there to right size your resources. So whether you're using Azure Migrate or the data migration service or the ADS tools, we allow you to input your performance data and choose the right machine that's big enough for what you're trying to do. You always want to take advantage of the Azure Hybrid benefit and the Azure Reserved Instances. Do the reservations earlier rather than later. There's this thought that everybody has. It's like this natural inclination that I want to get the environment completely stable and then apply the reservations. But you can lose months of savings that way. It's very easy to take a reservation and exchange it for another one as long as you're just changing the size of your resource. So do the reservation sooner rather than later because you want to lock in that savings. It's significant. Some other best practices for post-migration, make sure you're using Azure Policy, make sure you're using Azure Advisor, make sure you're looking at Azure Cost Management. You really want to use all the tools that are out there to manage your costs. As far as during the migration, how many folks have heard of the AMP program? So the AMP program is one of our cooler programs. It has two tracks. There's the self-guided and there's the expert help where somebody will take you through the process. The self-guided is all the resources are out there online. You can go out there and you can start using that. And that's at azure.com/amp. If you have a big migration, if you're moving an entire data center, there's also links on that page to go and request the guided experience where we'll have engineers with a lot of experience actually guide you through the process of the migration. So you'll have a coach assigned to you who can really help you through everything. As far as the best practices go to getting to the cloud, you always want to prioritize the assessments. And part of that means allowing enough time for them. One of the things that we see people get in trouble with is they don't collect enough data for the SKU recommendations. So if you're collecting, a couple hours of data on a Tuesday afternoon when not much is going on, and you're using that to size your machine, that could be trouble on the weekend when you run your weekend processing and your backups, your check DBs and all that. You're going to run the box right out. So if you have an idea when the busiest time is, you want to make sure to do your assessment during those times. You want to anticipate and mitigate complexities. We've all been doing IT for a long time. We know that there's no simple thing. There's always something that comes up. So, build in some time in your schedules and be able to just roll with it. You think, what's next? How can I go? And that goes right into executing it early. You want to pick a good workload to start with and then build muscle over time and just keep iterating and iterating until you've got really a good process down amongst your team to be able to do your migrations. So we've got some links in here to get started. I'll make sure to upload my deck so you'll be able to get these links. And then we've also got additional resources in here that'll be available with the deck. So that gets us to the end.